Calculate the standard cell potentials of galvanic cell in which the following reactions take place. Chromium, cadmium ions are giving you chromium ions plus cadmium. Ferrous with Ag plus is giving you ferric plus silver. अब ये आपको reactions दिए गए हैं. Calculate the delta G naught and equilibrium constant of the reactions. How do we do this? Well, actually we would need some data. There's no data given except for the reactions. But actually if you look in NCERT, there is a table. Yes. And if you look at this table, a lot of E naught values are given for the half reactions, and this is the table you would need to consult. So, what all has been asked? Let's take a look. It is chromium, cadmium, ferrous, ferric and silver. So, do we see any chromium, cadmium, ferrous, ferric, silver here? Let's take a look. We have, well, ferric to ferrous. Ferric to ferrous, the standard reduction potential, this is 0.77, and Ag plus to Ag, it is 0.8. So we have two data. Fine. Do we have more? Yes. We need for chromium and we need for cadmium. For chromium and cadmium, chromium is here. How much is that? Chromium, the SRP is minus 0.74. Okay. And for cadmium, that would be, let's see if cadmium is somewhere offered. Otherwise, we would need to find out from a separate source. It doesn't look like as if cadmium is very much included here, but we would need the data on cadmium for the E naught value. But let's solve with what we have. So from that table, we have noted these values. SRP of Ag plus to Ag, ferric to ferrous, Cr3 plus to Cr. Cadmium is missing in that table, but we would need the value for. So I have taken this value from an independent source. Please note, in absence of this value, you would not be able to solve this problem. This is a data which should be given in the question. Now, let's take a look at part 1. Part 1 says, the reaction is chromium is undergoing oxidation and cadmium is undergoing reduction. And whichever undergoes oxidation is anode and whichever undergoes reduction is cathode. Wow. So how do I find out E naught cell? I can say E naught cell is E naught cathode minus E naught anode. Reduction potential of cathode, and what is that? Cadmium 2 plus to cadmium, that is how much? Minus 0.4 volts. Minus of reduction potential of anode. Now anode, actually what happens? Actually oxidation happens at anode. But then why are we writing minus? Because if we negate it, if we put a minus sign, that means we are reversing the reduction reaction and we are actually converting this to oxidation reaction. And oxidation is something which actually happens at anode. So that is minus of 0.74, which is plus 0.74 minus 0.4, and how much that is? Plus 0.34 volts. So E naught cell, I have just calculated E naught cell by the formula. It is simply 0.34 volts. And we know very well the reaction is what? It is Cd2 plus 2 electron giving you Cd. So N, the number of electrons, the value is 2. And delta G naught is minus NF E naught. Oh no, N is not. I mean, for this half reaction, N is 2, that's fine. But then we have a bigger reaction. We have this kind of a reaction. So for one cadmium, the value of N is 2. And if there are 3 cadmiums, that means a total of 6 electrons are being exchanged. So N, the value of N now becomes 3 into 2, which is 6 for this reaction. Oh, you have confused us. Let me repeat. What is N? N is the number of electrons involved in the half reaction or full reaction, depending upon whether you are writing it for half reaction or full reaction. Now, when you are writing it for a cell reaction is a full reaction. So, you are supposed to write N for a full cell. And how much is that? Total number of electrons lost by anode or gained by cathode as per the balanced reaction. One chromium loses 3 electrons, 2 chromiums lose 6. N key value is 6. Or if you look at cadmium, one cadmium gains 2 electrons, 3 cadmiums gain 6 electrons. Whichever way you look, the value of N comes out to be 6. So this is minus 6,96500 coulombs per mole into E naught. How much is E naught? That is 0.34 volts. Oh my God. That's it, that's it. What do? We just calculate. I'll do that for you, of course, but then this is delta G naught. What about equilibrium constant? Delta G naught is also equal to minus RT ln K. Oh my God. So can we find out K from here? Of course we can. And what is that K? Ln K, yeah, log to the base 10 of K is minus 1 upon 2.303 RT into delta G naught. And delta G naught is nothing but minus NF E naught. So this is minus NF E naught upon 2.303 RT. Oh, that looks ugly. That's not ugly. It's beautiful. Temperature has not been mentioned, but since nothing has been mentioned, let us be shameless enough to take temperature as 298 Kelvin, because this is usually what is done. If nothing has been mentioned, we just assume it to be 25 degrees Celsius, 1 atmosphere. Okay, assuming that, if you substitute these values here, N of course is 6, whatever, and we have this ready calculation with us anyways in the form of formula. Delta G naught is minus NF E naught. If you substitute this value of all this funny thing, 2.303 RT, F, etc., etc., this is, you remember that number 0.0591? Yeah, that is the calculation which you actually get. It is useful to remember that simply because it does not remain as ugly as that. So this is minus 6 times, of course, E naught by, so this is minus of delta G naught, that means plus. Delta G naught is minus NF E naught, and minus of minus becomes plus here. There was a silly mistake, we have just corrected that. So this is 6 E naught by, the whole drama comes out to be 0.0591. Oh my God. What do? E naught, we are aware it is 0.34. This is 6 into 0.34 by 0.0591. Let's calculate that, and then when we do the antilog, we get the value of K. If you take a look at the answers, it's a little dirty calculation, but it comes out to be how much? Well, you get your delta G naught value as 196.86 kilojoules per mole. Don't you forget, E naught cell was 0.34 volts. K, if you calculate, it's around, you can very well guess. See, I can tell you how to get the order of magnitude. Now, this is a very accurate calculation. If you're interested, I can also guide you with rough calculations. But then when you're taking antilogs, please remember the error becomes greatly enhanced in case you are taking antilogs. So that becomes a bit dangerous. But let's see, 0.0591, if I approximate this as 0.06. Now I have raised this a little. So 0.34. Now 0.001, I have increased it by 0.0009. Fine. So what happens here? Maybe this might be slightly enhanced. Instead of 0.34, it could be 0.341 or 342, something of that kind. But then if I do this, I get this value as 34 or 34 point something. 34 point something. This is what I get. And if I take antilog, one thing I am sure, that it is something. See, because this is mantissa. So whatever antilog comes, that antilog would be here, and that is very sensitive to what the kind of approximation you've made. But then 10 raised to 34, this is very clear. You can get 10 to the power 34 clearly from this approximate calculation also. So it is a careful, it's a very good method for cross-checking. In case you get a multiple choice question like ABCD options, and if there's only one option with 10 to power 34, you don't have to calculate accurately also. You could have calculated like this also. But otherwise, please remember, whenever you have to take antilog, it becomes highly sensitive to approximations. So even if you make a very minor mistake here, it would be highly magnified on taking antilogs. So you have to be careful, and you have to be very accurate when you are calculating this portion, right? This was first part. What about the second part? It's a very similar thing. You should do it now. We have done it. Well, so let's check. Let me also solve it for you and show how it is done. Now we are solving the second part, which says ferrous is oxidized to ferric. This is anode. And Ag plus is reduced to Ag, which is cathode. Well, pretty lovely. We are having SRP values of both. And E naught cell is E naught cathode minus E naught anode. Cathode is silver. So that is 0.8 minus 0.77. This is 0.03 volts. That is pretty small, yes. Nonetheless, what about the value of N? If you care to just see, the value of N is simply 1. Why? Because Ag plus to Ag, 1 electron, ferrous to ferric, 1 electron only. So, delta G naught, which is minus NF E naught, which is minus 1 into F, 96500 coulombs per mole, into E naught is 0.03 volts. Volts into coulomb is joules, to joules per mole. And if this is 96.512. Sorry, 965 into 3. If I just, this so many joules per mole. How much would that come out to be? Let's multiply and see. 5 3s are 15, 18, 19, 6 3s are 27, 28. So I get 28, 95 or 2.895 kilojoules per mole. That's a reasonably small value. Yes, it has reduced. It is 2.9 kilojoules per mole roughly. This is the value of course with the negative sign. So minus 2.9 kilojoules per mole. What about value of K? Let's solve that out. That's not difficult. We have just seen log to the base 10 of K is N into E naught upon 0.0591. We just did that, right? So how much is N? N is 1. What about E naught? E naught is 0.03 volts up by 0.0591. How much does that come out to be? That is 1 by 1.29, 9s are 27, 97. That's, well, not very encouraging, but whatever the number looks like. When we take antilog, K comes out to be, we can calculate this, carry out calculations, take the antilog. And the antilog gives a value of 3.22. Oh wow, that's it, that's it. This is the equilibrium constant, which shows that slightly it is pushed in the forward direction. And I mean, both the species have roughly same tendency to exist. This was the question.